Welcome to my multi-part series on the Mercedes M272 V6 and the M273 V8 engines. I've chosen to focus on what I'm going to call the 100,000 mile inspection. In this video, I'm going to focus on the secondary air injection system. And the heart and soul of this system is this electric pump. Now, this is not unique to Mercedes-Benz. A lot of cars use similar systems because this is a key system to meet emission requirements. So when you're dealing with the secondary air injection system, if you have a problem, you're going to get a check engine light. I'm not going to focus on all the issues related to check engine lights, but I do want to focus on some things you can check to prevent the check engine light from coming on down the road. Is you want to make these cars more reliable. We're doing this inspection at 100K so you can go another 100K without worrying when you're out on a road trip that you're going to have some sort of problem. So I'm going to start out with this V6 here, and I'm just going to explain the key components in the system because it involves more than just this electric pump. And then I'm going to take you over to the V8 and we'll see how that system is actually performing. I want to start by doing a quick overview of the system. It's the same on the V6 as it is on the V8. Here's a location of the electric pump, which you saw earlier. It's mounted right here. And this hose here is connected to the air filter housing, so air enters the pump through this, so you get filtered air entering the pump. And then it exits the pump in two locations. One location right here, and this location down here at the bottom. It goes into these two valves here. The valves are identical, same thing, V6 or V8. And you've probably heard people call these EGR valves. Oh, you got to check your EGR valves. Well, EGR means exhaust gas recirculation. Maybe you've heard this valve called a check valve. Maybe you've heard it called a gate valve. Or some people call it a control valve. Whatever it is, it's not really an EGR valve. I like to call this a control valve because it's controlling the air going into the exhaust. The purpose of the pump is to start up when the engine's cold, to pump fresh air into the exhaust, to heat up the catalytic converter more quickly. So this is definitely emissions related. As I said, if you have a problem with any of these components either failing or not operating, you're going to get a check engine light. Okay, so this is a control valve. It needs to open at the right time to allow this air that's being pumped here through this hose to go to the exhaust ports. There's also this electric solenoid valve which opens and allows vacuum to get to these two control valves because it's vacuum that will open them, and when vacuum is cut off by this valve, then they'll close. So this could be an issue too when you're doing your inspection. And so if there's something else wrong in the system, this air may not be getting to where it should go, and that's what we want to look at in this video. We want to inspect both the V6 and the V8 to determine how healthy these systems are and are they indeed working properly, because you may have some subtle problems with these and not get a check engine light. Now I'm going to explain a couple things you can do for a quick inspection of whether or not it's working properly. Here's one. After the engine has heated up, these two valves should be closed, and if you pull this off right here, there should be no airflow. It shouldn't be sucking or it shouldn't be blowing. If this is blowing air, that means there's exhaust coming out. You usually see staining around here. You may even see a little smoke. That tells you that either one or both of these valves are not completely closing, and while the engine's running, the exhaust is going to come back up into the pump and come out here. So if you install a new pump and don't inspect the rest of the system, exhaust gases backing into the pump could quickly ruin your new pump. The other thing is noise. If you have a lot of noise grinding or growling noise on the front of your engine, it's probably either this pump is wearing out, still running, won't throw a check engine light, or it could be one of these pulleys here. So don't just assume this. So what I'm going to do now is show you how to test this for sound, because the sound is going to give you an indication of how much life is left on your pump. I want you to hear what this new pump sounds like, because that's going to be your reference when we go listen to the pumps on these other engines. You can power them directly with 12 volts. You see, this is the way it mounts on the engine. So this lower pin is positive, the upper pin is negative. All right, I'm going to hold it off and I'll turn it on, and we're just going to take a second and listen to it. It's also blowing a nice strong stream of air. So there's the sound you want to hear. Now that you got to hear a brand new secondary air pump run on the bench, let's try this one on the V6. Okay, a couple things we're looking for is any kind of a screeching noise. We're also putting our hand on these and checking for excessive vibration. Now for 92,000 miles, this sounds pretty good. So I don't think I need to check this for maybe the next 20,000 miles. So this is a pass. Now I have 12 volt power hooked up directly to the pump on the V8 engine. I did something else here. I removed this little hose so we could check output. You can feel it. I mean, it should be a strong, steady flow of air. It's not like a compressor. It's not going to blow your hand away. Okay, let's turn this one on and listen. Put my hand on, check the vibration. Look at that, nice output. This pump sounds fine. If you hear grinding and bearing noise, I recommend you change it before it fails. But for this pump here, it gets a pass. There's one other thing that you can check electrically, and that's this solenoid valve. This is electrically operated. The plug's right back here. You could pull the plug and apply 12 volt power. This is the valve that takes engine vacuum. Here's the check valve. And by the way, I'm going to change that check valve just because it's old. It's not expensive. And then routes the vacuum down to these two control valves. So if the control valves are not opening at all, it could be this solenoid valve right here. But I'm not going to do anything with this on either engine because I have no indications of a problem and no check engine lights. Now I want to explain how I test and inspect these valves. On this top one here, you may have to remove some of these plugs and get them out of the way because we're going to remove this vacuum hose coming into the top of the valve. I'm going to get a little pick tool, and I'm just going to get in behind. You don't want to pull on it because that's not going to work. You want to kind of roll it out. All right. We're going to take that off. Now, sometimes you will find these extremely rigid and hard. They may even be loose. The problem is these get hot and the heat is distributed as first section. So I recommend you change these vacuum hoses upon completing the inspection. So we're removing the vacuum hose so we can test operation. I'm using a vacuum hand pump tester to test the operation of the valve. When vacuum is applied here, it opens a valve inside, and when vacuum is released, the valve closes. So I want to determine if the valve is opening and closing, it's not stuck. So I'm going to put this on the end where I just removed that vacuum hose, and watch. It should pump up and hold vacuum. And when I release the hose, you should hear a clunk, indicating that the valve is closing. Here we go. Nice, look at that. Holding vacuum steady. Listen as I pull the hose. Clunk. All right, so that one's working. Let's bring it up to the top. We're going to do the same. Uh-oh, that's leaking down. It's not pulling it completely open. Now, if I remove the hose, it's not going clunk. Just barely you could hear it go down. It wasn't that solid clunk. Let's run over to the V6 and check those while I've got my tester in my hand. I'm testing the top one. See how steady it comes right up to almost 25 inches? Now listen as I remove this one. You hear this snap. Okay, that one's working okay. Then I'm going to come down below and get on this bottom one. Okay. Coming right up to 25, holding steady, release, snap. So operations-wise, we have one that's not functioning properly. Now, if these hoses are old and brittle, you're going to probably have to get replacements. But I'm looking at this one. It's still soft and flexible. I'm going to use a right angle pick tool. And I'm going to put it in here at 90 degrees. Get it under the rubber. All right, now I'm going to roll it all the way around. I should be able to pull this one off. Okay, that's off. And then we'll do the same here. All the way around underneath and pop it off. It's pretty hard to look down in there. The best way to do it is to grab your mirror and a pen light, and we're going to look right down inside there. See that? You can see the stem of the valve. If you see a lot of oily carbon and gunk in there, you're probably going to have to remove it, clean it out, or replace it. I have a little issue with this control valve here, so I'm going to remove it. Make sure I get this wire up and out. Yep, that's free. Everything else is free. Now I'll snug these down by hand and get them just tightened down snug. And then I'm going to bring in the 1/4-inch drive torque wrench, and we'll torque these to 9 Newton meters. You can see I unplugged a couple of these plugs and moved this out of the way. Here's this short section of vacuum hose I want to replace. Most of the time these will crack or break when you pull them off. So I'm going to cut a small piece of silicone vacuum hose, and that's what I include if you purchase a new control valve and gasket from me. But before I forget, I'm just going to stick this hose back on. It's kind of a toss-up. I tend to put both sides on together. Okay. All right, that's done.